So for question number 1, it asks, if a system is moving such as the one in problem 2, how does the mechanical energy calculation take into account the moving system? And the answer here is essentially that it takes a relative velocity rather than an absolute velocity compared to the control surface, which can be represented by this equation, where the relative velocity to the control surface is equal to the absolute velocity minus the velocity of the control surface. And this will be used later in question number 2. So question number 2 asks, if a person were to hold a 1 meter diameter turbine perpendicular and 2 meters away from their body and spun at a rate of 30 RPM, what is the work that would be generated by the turbine if the mechanical efficiency is 50%? And so we're looking at atmospheric pressure, mechanical efficiency is 0.5. We're asked to find the work generation, and we have to assume that the velocity of the air across the entirety of the turbine is constant and can be approximated as the velocity at the center of the turbine. And this is because the turbine is in reality moving in a circular path, and so the air velocity on the side farther away from the person will be higher than the air velocity on the side closer to the person. And so that makes an extremely difficult calculation, so we aren't given anything to do anything with that. And so we have to assume that the velocity is constant across the entire turbine and that it can be approximated by the velocity at the center. We're also given that it's going in a perpendicular path to the human, so z1 equals z2, and we are at the same conditions across the on both sides of the turbine because we're outside, and we can approximate v2 is equal to 0 because we are not given a change in velocity, and it is not possible to calculate work without assuming v2 is equal to 0. All right, so and then also given in the problem, the center of the turbine is 2 meters away from the axis of rotation. And finally, the properties, we're using density of air is 1.2 kilograms per meters cubed. So the first thing is to simplify the mechanical energy equation, where we can cancel out P2 minus P1 because they're equal, and we can cancel out Z2 minus Z1 because they're equal, and we can cancel out V2 squared because V2 is 0. So that simplifies our mechanical energy equation down to negative V1 squared over 2. And then we are able to find V1 by multiplying our RPM by the circumference and then simplifying units down to get 6.28 meters per second. We are then going to use the mechanical efficiency equation and plugging in our delta E mechanic equation from up here and multiplying by the mass flow rate. And then we have to find the mass flow rate, which is given to get 5.92 kilograms per second. And to finally get a work generation per unit of time as negative 58.4 watts or joules per second.